Today's lesson is on rational exponents. But before we get started, I'd like to tell you something that happened to me. My daughter really knows how to hold a grudge. She asked me to hand her some chapstick, and I accidentally gave her some super glue. And she hasn't spoken to me in over a month. Anyway, laws of exponents. Let's start with some old ones, and I'd like to give you an example to show you that you already know most of this stuff. Here, if we have x to the m times x to the n, you add exponents. And I say whenever they have their own base, that's when you know to add. For example, you have something like that, you just say 3 plus 5, and you'd get x to the 8th. Here, when you divide exponents, for example, you just subtract, and you'd get x to the 5th. Here, this is when they don't have their own base. That's when you multiply. And so we'd get x to the 6th. I'd like for you to be very clear on what a negative exponent does. It does not make the number negative. It means reciprocal. And notice that the negative sign is completely gone. And if you had a negative in the denominator, you just move it to the numerator. Okay? So the negative just means reciprocal. Okay, now this is the new one, and this is the one I really want you to pay attention to. Notice that the denominator goes here, okay, and that the numerator stays with the variable. There are a couple different parts. I want you to know this n is called the index, but more commonly or better known as the root. Okay, and whatever's under here, that's called the radicand. And that might be a new word for you. And of course, we know this is called the radical sign. So make sure you know those three names. You have the index is your n. The radicand is whatever's up under the radical sign. Okay, we'll practice this last one because this is definitely what today's lesson is all about. If you had x to the 2/3 power, that would be the cube root of x squared, or, watch this, the cube root of x squared. So notice you can put the square, which is the numerator, under the radical sign or completely on the outside. They mean the same thing. Alrighty, let's get to our first example. We're going to play a little fill in the blank. So here we have x to the 3/4 power. So that would be the 4th root of x cubed. Or you could put the cube on the outside. And I always like to use parentheses. Not entirely necessary. Now, we went that way. What if we go the other way? And we want to write it. We say this is with a rational exponent. Rational simply meaning fraction. Okay? So if I say, or you see directions that say write as a rational exponent, this is what you would do. You put the 5 in the numerator and the index is the denominator. The index is the denominator. Very important. Okay, here, what is the exponent, or what is the index, I should say? And whenever there's nothing there, it's always 2. So 2 is the invisible index or root, whichever word you prefer. And notice when there's nothing here as the exponent, it's 1. So this is x to the 1/2 power. And if ever it's reducible, if this fraction is reducible, you must reduce if possible. If possible, okay? Keep that in mind. So here, our index is 2. So the index is the denominator. And notice here, that's just 3, or 3 over 1. Here, I'm looking at 6 over 2. And I did this example because I want to make sure that you see that these two are the same. They're the same, absolutely. Whether the 6 is on the outside or underneath the radical sign. Alrighty, let's practice evaluating with numbers. Notice before we had variables. Now I'm giving you regular numbers. So what is the square root of 81? Well, we all know that the answer is 9, but I want to make sure you truly understand why. 81 can be written as 9 squared. And now, if we were to write this with a rational exponent, we understand that the index is 2, so that's 2 over 2, which is 9 to the first power, which is 9. And actually, to tell you the truth, that would be the absolute value of 9. And remember, when you take the absolute value, that always makes a number positive. Now, the rules are going to change up a little bit if there's a variable under there. But for now, the absolute value of 9 is positive 9. So now, let's look. This is the square root of 16 cubed. I could put that cube on the inside, but I don't know what 16 cubed is off the top of my head. So anyway, the square root of 16 is just 4. And now 4 cubed, I do know, is 64. So that would be my final answer. Alrighty, here I'm looking for the cube root of 8 to the 4th power. The cube root of 8 is 2, and 2 to the 4th power. That's 2 times 2 times 2 times 2. So 4 times 4 is 16. Wow, notice how those had the same answer. Interesting. Let's look here. What does the negative mean in the exponent? It means reciprocal. So it's still positive. Just remember that means reciprocal. And now for my denominator, that's the cube root of 27 squared. The cube root, 3 times 3 times 3. So that would be 3 squared. So my answer is 1/9. Okay, you'll get used to this with more practice. Now, let's throw a few more negative signs in there and see how you can handle that. Let's recall that the square root of -1 equals I. So if we were to simplify this radical, we would separate and we would get 13i. Okay, so I just don't want you to forget the things that you've learned in the past. Here, we're looking at the cube root. Now, let's think a little bit about cube roots. What is the cube root of -1? Well, isn't it true that -1 times -1 times -1 equals -1? So in other words, the cube root of -1 is just -1. Okay, so when you separate this, that's just -1 times 5, which is -5. And the thing I need you to always remember is that when you have odd index, and you might want to write this down, odd index never needs I. Never needs the imaginary number. Make sure you remember that. If it's an odd index, so that's if it's the cube root or fifth root or whatever. Okay, let's look at this one. This means reciprocal. So that's 1 over negative 8 to the positive 2/3. And now I'm looking at the cube root of negative 8 squared. So the cube root of negative 8, that's just negative 2. Remember, no I needed. Just leave it negative. If it's negative here, you make it negative here. And now we still have our square. And so that would just be 1/4 because negative times negative is positive. Okay. Hopefully, I'm not going too fast for you. If so, just pause. Okay. I need you to understand the even, odd rule. This is very important, and we've already used it a number of times this year. For example, here's a time when you used it and you didn't know why. Let's say we had x squared equals 36. And when we took the square root of x squared, we took the square root of both sides. I always said, remember, when you have a square and a square root, it's absolute value of x. Well, this rule is the reason why we had to go absolute value. Okay, this rule is the reason. If you have an even index and an even exponent, and your result had an odd exponent, that's the even, odd rule. Okay, so let's practice it to make sure you're okay with why we need the, and I shouldn't have gone over here with this. It's here. It's here. That's odd. So that's the even, odd rule. Let's practice it to make sure you're okay with it. If we look at part A, and we're looking at simplifying this, let's rewrite it with a rational exponent and reduce. And now we check to see if it meets the rule. Even, odd. That means it needs bars. Okay? And if this were in an equation, remember, we would remove the bars and make it plus or minus. But I also want to tell you, let's say this was the fourth root of 2 to the 12th power. And we made that 2 to the 3rd. You need bars, but what's the absolute value of 8? It's just 8. So there would be no bars because it's just a number and we can just make it positive and keep going. But when it's a variable, we don't know what the variable is. So therefore, we leave the bars on. Okay, so here, this is x. That's a 2. So that's 8 over 2. That's x to the 4th power. Even. So we do not apply the bars. We leave it alone. And the reason being is that if this is even, the negative would disappear anyway. Let's do another one. So again, no absolute value bars needed. Here, x 6 over 6, that reduces to 1. Even, odd. So we need bars. Only use bars if it's even, odd. And notice the numbers that we're checking. Index, under the radical, final result. Alrighty, let's do our last example. We're going to solve, and we're only going to look for the real solutions. Before, we would have found all three solutions by using the sum of cubes, and we would have a couple of imaginary ones. But for today, we're just going to look at the real solutions. Now, whenever you want to get x by itself, that's what it means to solve. Isolate x. So here, what we're going to do is we want that exponent to be a 1. So what I'm going to do is multiply by the reciprocal. So 2/3, but whatever you do to one side, you do to the other. So notice that cancels all out, and I just get x. And now I'm looking for the cube root of 8 squared. So that would be cube root of 8, 2 times 2 times 2. And 2 squared is 4. So 4 is my final answer. Here, I'm only looking for the real solutions. So I'm going to take the cube root. And I get x. Oh, I need to check. Not even. That's odd. So no bars. As a matter of fact, no bars are ever needed if you're doing an odd index. No bars for odd index. The odd indexes are very nice. No i's, no bars. We're good. Okay, so here I'm going to divide everything by 2. I'm trying to isolate x because that's what it means to solve. And now, how do I get rid of the 4th power? I take the 1/4 power on both sides like this, or that's the same as saying I'm going to take the 4th root. I prefer looking at it like this, but it's the 1/4 power. It means the same thing. But be careful, even, and this is odd because 4/4, let me make sure you see that, is 1. So I'm looking at even, odd. It's the same as canceling it out, but you have to put the bars or you won't get the right answer. And remember, what do you do when you remove the bars? You make the other side plus or minus. And so now I do an equation with the plus sign, or I do an equation with the minus sign. I do both. Okay? So I get x equals -3 or x equals -7. So I have 2 real solutions. Notice the original equation was 4th power, which lets me know there's 2 real solutions and 2 imaginary solutions. We didn't find the imaginary solutions right now.